All right, for section 7.2, day 2, we're still graphing today. The only difference is I'm going to add more things to the top as compared to the bottom. Okay, there's going to be a couple more things that I add to it. We're going to add some asymptotes. We're also going to add another type of asymptote to you. On Friday, you guys did vertical asymptotes, which were the ones that went up and down. I'm also going to add in the horizontal asymptote today. Okay. Other than the y equals 0, it's not going to be necessarily, or not, yeah, y equals 0 might be something a little bit different. So here's the type that you're going to see for the first type is it's going to say graph, and it's going to say f of x equals 2x plus 1 over x minus 3. Okay? So you've got a little bit more on the top than what was on the bottom. Okay, so that's going to be the difference, is that you're going to have more stuff on the top. Okay, on Friday, if you don't remember, when we did the top, it was just a single number. Okay, not a bunch of things. Okay, so first thing, in order to help you get started with it, the vertical asymptote, which I'm going to abbreviate as VA. Remember, that's where we set the bottom equal to 0. Okay, so you set the bottom equal to 0 is how you find it. And solve. Okay, so what is the bottom? X minus 3. So x minus 3 equals 0. X equals 3. Okay, that is the vertical asymptote. Okay, which means everything got shifted over 3 units. Everybody okay with that? Okay. Now, as far as the horizontal asymptote, the one that goes left to right, it's a little bit different. Okay, and your book doesn't talk about it like this, so I'm going to talk to you about it, how it actually works, okay, to make it easier for yourself. There's 3 different criteria. Okay, the 3 different types of criteria are based on the degrees. Now, your particular problems will probably only look like this, so it won't be too terrible. But when you get into the upper college algebra stuff, your degrees are going to change. What's a degree? A degree is the highest exponent. Okay? And as far as the way that that works, there's 3 different types. First of all, when the top degree is bigger than the bottom degree. Okay? When the top is bigger than the bottom, there will be none. And this is for the horizontal asymptote, the one that runs left to right. So if the highest exponent on the top is bigger than the highest exponent on the bottom, we don't have one. Okay? Now, this particular problem, that's not the situation. That's not the scenario. The second scenario is when the top degree is equal to the bottom degree. By the way, in our problem that I gave you, what is the highest exponent on the top? Not number in front, exponent. What's the highest exponent? 1. What's the highest exponent on the bottom? 1. So notice the top degree is equal to the bottom degree. Okay, so this is our situation. For everyone that are like this type, this is the scenario that's going to happen. Then it's y equals the lead coefficient of the top divided by the lead coefficient of the bottom. Now, do you remember what coefficient means? It's been a while since I've maybe used that word, but what is a coefficient? It's the number in front of the x. So when you guys were telling me 2 for the degree, you were actually telling me the coefficient. Okay? Degree, again, is the highest exponent. Coefficient are the number in front. So 1 and 1, it's the same. So what's the lead coefficient of the top? 2. What's the lead coefficient of the bottom? 1. What's 2 divided by 1? That's your or horizontal asymptote. So for this particular one, we'd have y equals 2. Now, there is one other scenario. What's the only other scenario we haven't talked about? When the top degree is smaller than the bottom. Okay? And I got to use a new slide for that one. Sorry, guys. So when the top degree is smaller than the bottom degree, it's going to be y equals 0. So let's say the highest exponent on the top was 8 and the bottom was 10. 8 smaller than 10, yeah? So therefore, y equals 0 would be our asymptote. Okay? Now, for our particular problem, what was the vertical asymptote that you guys found? X equaled what? What did x equal? 3. So go over 1, 2, 3. Make dashed line. Remember, an asymptote is a line that it comes right up to but does not cross. What was our horizontal asymptote, or the one that went y equals? 2. 1, 2. Make a horizontal line that runs left to right. Now, as far as what's going to happen for the graph, the picture, how do you get the picture? How are you guys been getting the picture on your assignment you turned in today? You put it in the calculator and saw what you got. Or, if you didn't like that, you could have put in random numbers for x and see where it's located, right? Anybody put it in yet? What's it look like? So you got one that's coming in here like so, right? And then you got the other one coming up here in that one. That spot. Okay? Now, the other part to this problem that we need to also address, and that is something that I forgot to do on Friday, but we're going to do it now so that way we know. It will ask you what the domain and what the range is. Okay? And that was something that it came up on Friday. Some people asked me, and I said, we'll wait till today. Here it is. Here's how we do it. The domain. Remember, the domain is nothing more than the x values that work. So, everything's working all the way up from where I'm at, all the way up to here. What's the only number that it does not work at? Not 2. 3. Because if you were to put 3 in, you would be dividing by 0 in the problem. And can you divide by 0? No. The 11th commandment states, thou shalt not divide by 0, so therefore not possible. So how do you write everything except 3? You can write it out as all real numbers except 3. That's an option. How about x cannot equal 3? Would that be an option? Yeah. You could do something like this where you said x is greater than 3 and less than 3. That would be an option. The other thing that your book doesn't necessarily go through a whole lot, but when you get to college, it's going to be written like this. Negative infinity to 3, union, 3 to infinity. In that interval notation stuff that I've been showing you all year. Okay? That just means that 3 is the left out spot. Kind of like this, like I'm going to come right up to the number 3 and then jump over it. Because I didn't want to fall in the big hole. Okay? Now, the range is the y values that work. So what's the only y value that doesn't work? 2. So I do the same thing that I did for the range, or the domain for the range, but this time it's not 3, it's 2. So the range is y cannot equal 2 or 2 is greater than y, which is greater than 2, or negative infinity to 2, 2 to infinity. Okay? That's what they mean by domain and range. They're trying to get you to tell me what numbers don't work, okay, or what numbers do work. Your asymptotes are the numbers that don't work. Okay, does that make sense? So when we got 3, that was the one that went vertical, straight up and down, based on the bottom equals 0. When we got 2, that was based on the horizontal one, the one that we got based off of lead coefficient over lead coefficient. What do you think? Not too terrible? So then, another one. F of x equals 3x minus 1 over x plus 2. To help us out, first thing I'm going to do, I want to find the asymptotes. Vertical asymptote. Set the bottom equal to 0. What is the bottom? X plus 2 equals 0. And when I solve for x, I get x equals negative 2. Now, to find the horizontal asymptote. And again, just so that you guys are aware of this, I'm abbreviating. Vertical asymptote is VA. Horizontal asymptote is HA. Okay? Look at the degrees for the problem. What's the degree of the top? 1. What's the degree of the bottom? 1. Highest exponent. What's the highest exponent on the x on the top? 1. Highest exponent on the bottom? 1. They're the same. As soon as they're the same, you put the lead coefficient, which is 3, over the bottom lead coefficient, which is 1. And 3 divided by 1 is 3. So y equals 3. So on my graph, negative 2, 1, 2, make my vertical asymptote. Y equals 3, 1, 2, 3, make my asymptote. Is everybody okay with how I got the asymptotes? Now, there's something else that might help you for your graph, make it look even better. If you want to find the intercepts, okay, intercepts are nothing more than where does it cross the x and y axis. To get the x-intercept, you put the top equal to 0. That's how you find the x-intercept. So 3x minus 1 equals 0. How would you get x? What do you do to solve it? Add 1, and then what? Divide by 3, so you get x equals 1/3, which means 1/3 is approximately here. Then to get the y-intercept, it's even easier. You take the constant of the top. Do you know what I mean by constant? The number not attached to any letter, right? Divided by the constant of the bottom. What is the constant of the top? Negative 1. What's the constant of the bottom? 2. You just found the y-intercept. So based off of that, what I just did for that is I found probably it's going to be down in that lower right-hand spot. That's my guess, right? Those of you who typed it in, do you see something down here? Okay, now I just have a specific spot where they're located at. By the way, what's the domain? Everything except for negative 2. Okay, what's the range? Everything except for 3. Okay, so the domain, I like to put it in interval notation. So I'm going to do that. Negative 2 to infinity. And the range, you said everything but 3, right? Negative infinity to 3. 3 to infinity. By the way, I only have half the picture drawn. What's the other? Where's the other half at? The top left or right? Left? Okay. So up in here. What do you guys think? Not too bad? Okay, now, the thing that's going to be different from what we did on Friday to today, obviously, if you notice, the shapes are the same. The difference is now I'm moving it over. Okay? Those are kind of the how-tos as far as shifting the stuff over. Then, the last type that they're going to give you is they're going to ask you to rewrite it. So they're going to give you something like this, where it's 3x plus 5 divided by x plus 1. And they want you to write it like in this format. G of x equals a over x minus h plus k. They want you to rewrite it in that form. Okay? There's a little bit of a process to that. The process is, as far as rewriting it, we're going to use a technique called long division. Okay? Do you know what long division is? You put the divisor on the outside, the dividend on the inside. Okay, so what goes on the outside? X plus 1. Good. What goes on the inside? Awesome. Now, when you do long division when it comes to letters, first thing I'm going to ask you is, what times x gives me 3x? 3. So when you do that, you put the 3 on the top. Then when you did long division way back a long time ago when you were like 4th, 5th grade, maybe 6th grade, somewhere in that vicinity, you took this number that you just said and times it by the outside things. Well, what is 3 times x plus 1? 3x plus 3. Then what you did was, once you wrote it underneath there, then you subtracted it, correct? Now, here's where most people mess this up. They write a subtraction symbol here and they just leave it alone. Well, then they usually put the plus sign here. What's the problem with that? They subtract here just fine. But do they remember that it's 5 minus 3? Probably not. So, here's something that I do that I don't know if it helps you, but I do this, and my college students hear this all the time when I do this. But draw your line, switch your signs, add straight down. So, what happens with the 3 x's? They're gone. What's 5 minus 3? 2. Now, quick question for you. Is there a way then to times it by x to give me a 2? No. Okay? So, for this particular thing, when you write it, here's the rewritten form. 2 is the a. And 3 is the k. All right? Now it kind of looks like what we did on Friday. Because here's how it's technically written. Okay, Hunter? This is the quotient plus the remainder over the divisor. It's very similar to if I were to ask you to what's 13/4 as a mixed number. You'd divide it, and then you'd have your remainder, whatever's left over. So how many times is this 4 go into 13? 3 times. So 3 is the whole number. And then the remainder would be 1 over 4 1 over 4. Same concept, just with letters. Okay? Then from there, if they ask you to graph it, could you graph that? Either using this form we just created or the other form that we had before? Absolutely. Could you describe the transformations that took place? Yeah. Up 3. Vertical. Stretch by 2. Right? Okay. I left this up on the board for a reason, where it's got top and bottom like that for outside and inside, just so that way you guys could remember where it's supposed to go. Okay, we talked about it briefly out loud on Friday, and then I ended up writing that later. I left that up there for you guys. Okay? What do you think? You guys comfortable with that? Do you want to do another one? Okay, so if not, here's what I got for you. On page 371, 28 to 38 evens, 41, 42, and 46.